You know, we spend all day long clicking, typing, and swiping on our devices. But have you ever stopped to think about what's actually happening inside that metal box? It feels like magic, but it's not. It's an incredibly fast chain of events. So today, we're going to pull back the curtain and follow the journey of one single click.
Right, so think about it. You move your mouse, the little arrow lands on an icon, and you click. And then, faster than you can blink, a whole program opens up. But what happens in that blink of an eye? What is the unbelievable high-speed journey your command just took to make that happen? Well, that's exactly what we're going to break down.
The very first thing you have to get is that a computer doesn't speak our language. Not at all. The physical press of a mouse button, that means absolutely nothing to it directly. That simple click has to be translated. It's a journey out of our physical world and into the computer's world, a place built entirely on electricity, on zeros and ones.
So every single command we give, no matter how simple, has to first be translated into the computer's native language. Let's dive into that secret vocabulary, because it's the foundation for literally everything else.
A computer, at its very core, is just a massive collection of tiny electronic switches. And a switch can only be in one of two states, right? It's either on, with electricity flowing through it, or it's off, with no electricity. That's it. Every amazing thing a computer does, from rendering a 3D world in a game to just showing this text, has to be broken down into that simple two-state language, on or off.
To represent those on and off states, we use the absolute smallest piece of digital information there is, a bit. It's short for binary digit, and it's either a 1 to mean on or a 0 to mean off. You can think of a bit as the atom of the digital world. It is the fundamental building block of everything.
But of course, a single bit by itself can't hold much information. So to do anything useful, we have to string them together. We group them into a bundle with 8, and that's called a byte. Now, a single byte can represent 256 different combinations. That's enough for every letter of the alphabet, both uppercase and lowercase, all the numbers and all the symbols you use. Everything is just a long sequence of these bytes.
Okay, so our click has been translated into a bunch of ones and zeros. Great. But who reads this message? Who figures out what to do with it? For that, you need two key players, the computer's master conductor and its incredibly powerful brain.
The very first stop for your command is the operating system, or the OS. You know it as Windows, Mac OS, or Linux. The best way to think of the OS is like the conductor of a symphony orchestra. It doesn't actually play any of the instruments, but it directs all the different parts, the hardware, the software, making sure they all work together in perfect harmony.
So this handoff is absolutely critical. You click the icon, the OS sees that signal and goes, aha, they want to open this program. It then takes that request and passes it on to the component that does all the real heavy lifting, the computer's brain. And that brain is the CPU, the central processing unit. If the OS is the conductor, the CPU is the entire orchestra, doing all the actual work. Its one job is to follow instructions and perform calculations at mind-boggling speeds. It is the engine that drives everything your computer does.
So, how fast are we talking here? Well, you've probably seen a number like this on a computer spec sheet. 3 gigahertz, or GHz. What on earth does that mean? It's the CPU's clock speed. Think of it like a metronome. It sends out a pulse to keep everything in sync. A 3 gigahertz CPU can perform 3 times billion of these cycles, these basic calculations every single second. Our one little click gets handled in a tiny fraction of that time.
So now the CPU has its orders from the OS. Run this program. Easy enough. But to run the program, it needs the program's files, its code, its data. And all that stuff is stored in the computer's memory. But as you're about to see, there are actually 2 very different kinds of memory, and they each have a very specific job.
The absolute best way to think about this is with an analogy. Your permanent storage, your hard drive or your SSD, that's like a huge library. It holds all of your programs and all your files, safely for the long haul, even when the power is off. But RAM, or random access memory, that's like the workbench sitting right in front of the CPU. It's a temporary, super fast workspace where the CPU puts only the tools and documents it's working on right this second. The catch? When you turn off the power, that whole workbench gets wiped clean.
So why do we need both? Why not just have one giant, super fast thing? Well, it all comes down to a trade-off between speed, cost, and whether it remembers things. RAM is insanely fast, but it's really expensive, and like we said, it's forgetful. Storage is way slower, but it's cheap, and it remembers forever. This is why having enough RAM is so important for performance. It gives your CPU a bigger workbench so it can juggle more tasks at once.
So here's the key moment in our journey. When you click that icon, the CPU gets the command. It then reaches into the library, your storage drive, grabs the program you asked for, and makes a copy of it onto its workbench, the RAM. Only then, with the program sitting in that high-speed workspace, can the CPU actually start to do its job.
Okay, so we've met the conductor, the brain, the workbench, and the library. But these are all separate physical parts. How do they all talk to each other instantly? They need some kind of communication network, a central nervous system for the whole machine. And that nervous system is the motherboard. It's that big circuit board you see inside a computer. It's basically the backbone of the entire system. Every single important component plugs directly into it. And that's what allows them all to communicate.
The motherboard is really the grand central station for all the data. It's got these little electronic highways that connect the brain to the workbench and the workbench to the library. And it connects everything else too, your graphics card, your sound card, even the USB port you plugged your mouse into. Without the motherboard, you just have a box full of cool but totally useless parts.
Our journey is almost over. The command was translated into binary. The OS sent it to the CPU, the program was pulled from storage into RAM, and the CPU has done all the hard work. The computer has done the thing. But there's one last crucial step, showing us the result. So the CPU, after doing all its calculations in RAM, sends the final result to a specialist, the graphics card. The graphics card has one job and one job only: to translate all that raw data into a picture, a map of pixels that your monitor can actually understand. It tells every single tiny dot on your screen exactly what color to be hundreds of times a second. And the result? That program window pops up right on your screen.
And there you have it. In way, way less time than it takes to blink, your simple physical click has traveled from your finger, through a translator, a conductor, a brain, a library, a workbench, and a nervous system, finally arriving at a visual artist that painted the result right in front of your eyes.
So the next time you click on an icon, just take a second to remember what you're really doing. You're not just doing something simple. You're kicking off this perfectly choreographed, high-speed dance with all these incredible components working together in perfect harmony just to bring your intention to life. It is an amazing and beautiful system, but it's always changing, always evolving. So the final thought I want to leave you with is this. What's next? What kind of new tech, things like quantum processors or even brain-computer interfaces, are going to come along and completely change this fundamental dance? It's a pretty exciting thing to think about. Thanks for joining me.